esters. So first, for naming esters. So if you have the ester functional group, okay, so say if we have 2 carbons there, so that is called, that bit there, that is called ethyl. 2 carbons is ethyl. And then if we just have 1 carbon on this side here, 1 carbon there, then that is called methane. But take the E off, methane, and then the functional group is called O8. So the ester is called ethyl methanoate. Ethyl methanoate is the ester. Okay, right, that's how you name an ester. How do you make an ester? How to make an ester. How to make an ester. Okay, so the most simplest way to make an ester is if you take a carboxylic acid, like ethanoic acid for example. I'm going to draw it out as well, so you can see it drawn out. Ethanoic acid. If you take a carboxylic acid and an alcohol, for example methanol, and if you have a catalyst, catalyst is concentrated sulfuric acid, and if you reflux, continually evaporation and condensation, reflux, then you can make an ester. Okay, so the ester will be, if you draw the ester out, we've got the carboxylic acid part of the ester and then the alcohol part. Okay, this part has come from the alcohol and this part has come from the carboxylic acid. That's from the alcohol, that's from the carboxylic acid. Okay, plus water. This ester will be called methyl ethanoate. Methyl, because it's 1 carbon, 2 carbons, ethanoate. O8 for the ester. Okay, what is actually happening here to help you remember this? What is happening is that we have got the lone pair from the oxygen that's coming in and attacking the carbon here. Yeah, so it's the oxygen here, and this is what is going to form water. Okay, to form water. That's one way to make an ester. Second way to make an ester is if you take a acid chloride. Acid chloride. Okay, I'm going to draw it out as well. Okay, it's called, this one's called Ethanoic Chloride. Ethanoic Chloride. The functional group is called either an acid chloride or an acyl chloride. It can be called either. It's a functional group. Okay, if you take that plus the alcohol and then you make the ester, and again what is happening is that the oxygen's coming in and attacking the carbon, and we get the HCl as the other product. So we have the ester, COOCH3, the same ester is made, but this time the other product is HCl, and that's another way to make an ester. Okay, the third way to make an ester, just give me a piece of paper. The third way to make an ester is with an anhydride, an acid anhydride. So if you take an anhydride, This is the third way to make an ester. If you take, for example, the anhydride, okay, this is called ethanoic anhydride. Ethanoic anhydride. Ethanoic anhydride. The functional group is called acid anhydride. Acid anhydride. Then, if you take the alcohol, just the same, like that, and again, a similar idea is happening. So if you've got a lone pair, that's going to come in and attack the carbon, and then, so you're leaving, you have H, and you have all of that item there as the leaving part, yeah? So you get your ester, just the same. It's the same ester, methyl ethanoate. But then the other item now is ethanoic acid. Ethanoic acid. So there are three ways to make an ester. Okay, so the first way to make an ester was with carboxylic acid. The second way to make an ester is with an acyl chloride, and then the third way to make an ester is with a acid anhydride. This way, with the acyl chloride, this is the most reactive. It's the most reactive way, and this is the second. The anhydride is the second most reactive, and then the carboxylic acid is the third most reactive. Okay, so the acyl chloride is very reactive. What is actually happening? Let's just look in a little bit more detail what is happening here, and the same with an acyl chloride. So the most reactive is an acyl chloride, which is very reactive. Okay, so what is happening is you've got your alcohol, your lone pair of electrons, okay, and slightly positive, slightly negative, and then so it is like a nucleophilic, because this is like a nucleophile, nucleophilic addition reaction. Okay, and then you get an intermediate, which is your O minus, like that, your O minus. I'm just going to put the OCH3 there and the Cl there, okay, and then what happens is that you have a elimination. Okay, the Cl gets eliminated, so CH3, C, double bond O, and there's your ester, and then the Cl joins with the H to give HCl. So it's called a nucleophilic addition dash elimination reaction. Okay, and the acyl chloride is so reactive because the Cl minus is a very good leaving group. A very good leaving group. If you take the anhydride leaving group is the CH3CO minus, COO minus, and that is a good leaving group, but the chloride is better. So it's actually called a nucleophilic addition-elimination reaction. But a good thing to remember is that it is always the oxygen of the alcohol is the oxygen here of the ester. Okay, so that's always from the alcohol, and that is from the carboxylic acid, the acid anhydride, or the acyl chloride. So this is how you make an ester. 3 ways to make an ester. However, there is an exception. Okay, there are some exceptions. If you take not an alcohol, but if you take a benzene ring with an OH, which is not an alcohol, it's called a phenol, okay, and it's not an alcohol, It's not an alcohol. You cannot make an ester with a carboxylic acid. If you take a carboxylic acid and you try and make an ester like that, to make an ester, that does not work. Okay, does not happen. To make an ester for a phenol, you need acyl chloride, or you need a acid anhydride. Carboxylic acid is not reactive enough. So if I said to you, how do I make this ester? In order to make that ester, I need phenol, and I need either an acyl chloride or an acid anhydride. Okay, so that's how you make an ester. So once you make an ester, you need to be able to break an ester up as well. The only thing you need to know about esters is how to make them and how to break them up. Breaking up an ester is called hydrolysis. Hydrolysis of an ester. Hydrolysis means breaking a bond with water or aqueous solution. Yeah, breaking a bond with water or aqueous solution. So if you take there's two types of hydrolysis. You can do acid hydrolysis. Okay, but let's go back how to make an ester. Right, now when you're making an ester, you can use carboxylic acid plus the alcohol, concentrated sulfuric acid reflux, to make an ester plus water. Now this is not a very good way to make an ester, because it gives quite a low percentage yield. And the reason why it gives a low percentage yield is that is because it's actually in equilibrium. Okay, this making an ester is in equilibrium, so you never get 100% yield of ester. Right, so if we want to go in the reverse direction, if we want to break down the ester, then we need to add not concentrated acid, we need to add dilute acid. Because if we add dilute acid, if we add some water, that's going to push the equilibrium to the left, and make the ester break up. Okay, so we need dilute acid. So acid hydrolysis is just the same as the reverse of making an ester. So if we take, for example, this ester, and we want to break that bond, that's the bond that was made, that's the bond we're going to break. Okay, and if we take some acid in water and we use dilute acid, not concentrated, dilute acid, and we reflux it as well, then that bond breaks and we get back to the carboxylic acid and the alcohol. So it is just the reverse of esterification. Esterification is the name for making an ester. It's the reverse, and we're breaking that bond and we use dilute acid. Okay, it's not very good because it is in equilibrium. Okay, so how to make an ester, let's just put another word for there. How to make an ester is esterification. Esterification, how to make an ester. Okay, another way to make an ester, to break up an ester, is base hydrolysis, which is sometimes called alkaline hydrolysis as well. Sometimes called alkaline hydrolysis, but I call it base hydrolysis. It's called alkaline hydrolysis as well. Okay, this is where you take your ester and you reflux it with a base. So let's just take that ester and we add aqueous sodium hydroxide. Okay, and you reflux it as well. You reflux it too. And that will give you, and again it breaks this bond, but this time it gives you the salt, and gives you the salt of the, it gives you the salt like this, okay, plus water. And that is called the carboxylate salt. Its specific name is a sodium. This one will be called sodium. You name it a bit like an ester, Ethanoic, and it's called a carboxylate salt or carboxylate ion. Okay, sodium ethanoate, and that's how. And it's a very good way to hydrolyze an ester. It's got quite high yield. Then all you need to do is you just need to acidify, and then you just add acid. You acidify, and you get your carboxylic acid. Okay, so it's a really good. It's not reversible, high yield. Right. So that's all about esters. Final bit is just to mention about acyl chlorides. Just mention about acyl chlorides again. So acyl chlorides, because they come into this section as well, derivatives of carboxylic acids. Acyl chlorides, how do you prepare, how do you make an acyl chloride? Remember, an acyl chloride is this functional group, or acid chloride. Sometimes they're called acid chloride as well. So you've got to take a carboxylic acid, so I'm taking ethanoic acid. Then you add this compound, which is called a thionyl chloride. Thionyl chloride. And you make the acyl chloride. Okay, the one I've got here is ethanoyl chloride. Ethanoyl chloride. Ethan, because it's 2 carbons. It's not a nice preparation because you also make sulfur dioxide gas, which is really horrible, and you make a HCl gas, which is really horrible. So it needs to be done in a fume cupboard. These gases need to be got rid of in a fume cupboard. Okay, so once you've made the acyl chlorides are really reactive. Even in air, in the moist air, you'll start to see fumes, white fumes of hydrogen chloride gas. So you've got to be very, very careful. If you were to actually put a drop of water onto the acyl chloride, it's a really violent reaction, and you get white, steamy looking fumes of HCl. But it'll even fume in just air as well. And then you go back to the carboxylic acid, and HCl gas as well. Okay. Another thing you do with acyl chlorides, you make esters with acyl chlorides, but also you could, if you took ammonia, and if ammonia was the nucleophile, yeah, ammonia is the nucleophile, whoops, then it's very similar. This addition-elimination reaction happens, and you will end up with a functional group. So the N will come in, and it'll kick out the Cl, and you get HCl as the leaving, and that is called an amide. That functional group there is called amide. This particular molecule will be called ethanamide. Ethane amide. Right. This actually isn't the balanced equation though, because it's not going to make HCl, because as soon as HCl is made, it will react with ammonia to make ammonium chloride. So you need 2 ammonias and you need ammonium chloride. HCl is not actually going to exist. It'll react with the ammonia straight away. So that's the overall chemical equation. Right, the last one, if you take again an acyl chloride, but this time, instead of ammonia, react it with an amine, like methyl amine. Okay, very similar, the reaction's really similar. You'll get an addition-elimination reaction, and then you'll get, instead of the Cl, you'll get an N, which nitrogen can only have 3 bonds. So you've got to be really kind of careful. They can have 3 bonds on one of the H's in the Cl. Okay, and this is called an amide, but this will be called a secondary amide because there are 2 carbons. So it's called a secondary amide, whereas this one is called a primary amide because there's only 1 carbon. So that's amides. Okay. Oh, it won't be. Sorry, it won't be HCl, because what will happen? It won't be a HCl, because the same thing will happen again. We will need 2 of them, and the other item will not be HCl. It'll be the salt CH3, NH3 plus Cl minus. The plus should be on the nitrogen. Ammonium chloride, methyl ammonium chloride. Sorry, the plus should be on the nitrogen. Okay, that's not a very good end. I'm sorry.